I'm going to take a very quick tour, a rather superficial tour through this book by Brian Fagan on the long summer, how climate changed civilization. Has a couple of points that are worth looking at, and if you want, you should read the book. It's very readable, and he uses titles that are very evocative as well, starting with the threshold of vulnerability, and then splits it into three parts. So you can see the titles that are kind of very explicit in terms of links. So the Late Ice Age Orchestra, 18,000 to 3,500 year BC. The Virgin Continent, 15,000 to 11,000 BC. You can imagine what those things are. Europe during the Great Warming, 15,000 to 11,000 BC. And the 1,000-year drought between 11,000 to 10,000 BC. I think you can also imagine what this is, the Younger Dryas and its impacts. And the second part is the centuries of summer. So the cataclysm, 10,000 to 4,000 BC. Droughts and cities, 6,200 to 1,900 BC. Gifts of the desert, 6,000 to 3,100 BC in terms of evolution of agriculture, cattle culture, and so on. Part 3 is the distance between good and bad fortune. So this is the dance of air and ocean, 2,200 to 1,200 BC. You can guess what that is. So El Nino, we talked about the strengthening El Nino activity or variance of Nino 3.4 sea surface temperature anomaly index that we had talked about, and how that affected various regions like South America, especially Mesoamerica. Celts and Romans, 1200 BC to AD 900. The great droughts during AD 1 to 1200 more recently, so includes the Roman demise, the Dark Ages, and all the other civilizations we talked about, including the medieval warming and colonization of Greenland by the Vikings. Magnificent ruins also, AD 1 to 1200, and then the epilogue, AD 1200 to modern times, which goes through the Little Ice Age into the Industrial Revolution. So the chapters open with these kind of captions or little ditties. The Threshold of Vulnerability, for example, quotes Mark Twain, Life on the Mississippi from 1879. One who knows the Mississippi well promptly aver, not aloud but to himself, that 10,000 river commissions cannot tame that lawless stream, cannot curb it or confine it, cannot say to it, go here or go there, and cannot make it obey, cannot bar its path with an obstruction which will not tear down, dance over, and laugh at, which it will not tear down, dance over, and laugh at. So the idea is that you cannot really control a big river like the Mississippi, that it's going to do what it wants to do, and all the commissions and dams we build are going to be vulnerable. And it did happen during, I think, the 1993 flood, which was quite extensive and keeps happening over and over again. Looking at some of the major climatological and historical events that are listed here, that will revisit some of the ideas we have already discussed, but it's still worth going through again. So let's start here at 1600 BC, late Ice Age, coming out of the last glacial maximum. Though the Cro-Magnons in Europe, the humans forms, rapid retreat of ice sheet was the climate trigger. So there is implied climate determinism, because the book itself is saying how the long summer changed climate and changed civilizations. 1500 BC, some warming, variable temperature, climatic amelioration in Eurasia. So already we were trying to get out of the last ice age, but then we got hammered. 14,000 BC, There's a strong wind here, hopefully okay with the recording. Final ice age cultures in Europe. Rapid sea level rise was a climate trigger. 13,000 BC, Heinrich event ends. The first settlement of northeastern Siberia appears, and bowling Alarod, which is a warm period, rapid warming, was seen as a trigger as well. So the question, as we will see again, is during these ameliorations and warmings, was agriculture already being attempted, or without domesticating crops, was it being already part of a hunter-gatherer foraging lifestyle? 12,000 BC, Monteverde, Meadowcroft, first settlement of the Americas, cave paintings at Niort, France. So spread of forests in Europe. We already looked at the ecotone changes, and we'll revisit a little bit, that a little bit. Younger Dryas, Lake Agassiz spills. We'll look at that a little bit. Abu Huraira 1, Clovis in north. We talked about the different pathways they could have taken, either the gap between the Laurentide ice sheet and the other ice sheet to the west, or they took the coastal pathways. So Atlantic circulation shut down here, which created a abrupt and rapid warming, a cooling, which had severe impacts on the civilizations. Farming, and of course on the megafauna as well. Farming begins in southeastern Asia around 10,000 years ago, the trigger being drought in southeastern Asia, cold in Europe, and by 9000 BC the pre-boreal renewed warming had impacts on humans in terms of spreading of farming rapidly in southwestern Asia, Abu Huraira 2 and Jericho, so Levant regions, and moisture conditions and a resumption of the circulation acted as climate triggers there. We've seen this already many times, but this is a little bit more depictive in terms of the last glacial interstadial maximum at 21,000 years or so, and then slowly a warming, a little bit of up and down, the late glacial interstadial, so another warm period, 10,800 to 12,700 BC. Younger Dryas happened here around 9600 to 10,800 BC. So you have to keep converting BC to years ago. So this would add a couple of thousand years if we wanted to do years ago, calendar years ago, and so on. 6200 year BC event, or the 8250 event if you don't do BC and AD. And then this is the long summer that we are talking about. These are Greenland ice sheet core climatic records, so the temperatures shouldn't, or delta O18 should tell us when we were warm and when we were cold. So cold and dry on this side and warm and wet on this side. So this set us on a path of agriculture, whether it was a choice or whether it was something that was tried and didn't succeed here and succeeded here because of climate stability and how that changed societies, cultures, trades, and so on and so forth. There is the Lake Agassiz, which we've mentioned many times, but here it is looking at it on a map between Canada and the US of the current period, and there is the close in of it with glacial Lake Agassiz with current markers like Cedar Lake, Manitoba, Ontario, Minnesota, North and South Dakota are here, and Saskatchewan is over there. Lake Winnipegosis, Lake Winnipeg, Lake of the Woods, Red Lakes, and so on and so forth. Okay, so this is the one that was dammed during the glacial melt and then released lots of amounts into the Labrador Sea, Gin Sea region. Map of late Ice Age Europe, showing sites mentioned in the book, looking at the extent of glacier ice. You can go back and look at which period that is. Obviously, chapter 1. We were looking at 18,000 to 35 13,500. So that's kind of the map. We have still a Scandinavian ice sheet, Laurentide on the North American side. So alpine sheet was there. You have tundra, park and park tundra and mountain vegetation in some these gray regions. Boreal forests nestled between temperate and mixed forests in these lighter grayish colors here. Mediterranean vegetation. Mediterranean vegetation chiefly of dry and steppe types, prairies, long grass with scattered trees, and steppes. So obviously climate was beginning to recover and vegetation ecotones had been responding as well. This is the other side, looking at geologists' Beringia map of northeastern Siberia, bearing land and bridge, bearing land bridge and Alaska, showing major archaeological sites. So we have the Ushiki Lake here, Vekonieski Mountains, and so on. So again, we have tundra and steppe, woodlands, glaciers, submerged areas, and so on. So we have talked about this land bridge as being useful for crossing over and entrance of the Clovis and so on and so forth that we talked about before. Changing vegetation patterns in Europe as revealed by pollen analysis, in addition to what we already saw before. So we are looking here at North American sequence of summer temperatures, the warm period here, 4,500 to 7,000 year BC. Everything here is in BC, S10,150. So coming out the so-called Holocene climatic optimum. Altithermal is basically warmer periods during these Holocene years, and here is the time scale going again 12,000 BC to the Bowling Alerod, Cro-Magnons here. The vegetation types include boreal, Atlantic, subboreal, and subatlantic over time, and you can see the mix here in terms of herbs, heather, birch, pine, hazel, alder, elm, basswood, oak ash, elm, ivy, mistletoe, plantain, dock, wheat, beech, hornbeam, and sphagnum. Okay, so we had Cro-Magnons period, hunter-gatherers still, maybe eating some wild undomesticated cereals that may be growing around human settlements because humans were fertilizing the soil, as we talked about before. And come the Stone Age farmers, and Bronze Age and Iron Age follow. There is a lot of narrative that goes with it in the book. Obviously, as I said, I'm going to just jump through all that and just show some figures. So these are maps. This is the map of southwestern Asia before and during Younger Dryas, showing major archaeological sites again. Younger Dryas and the 1,000-year drought being a major driver, along with maybe the loss of megafauna that would have driven innovation of agriculture in many places, and its sustenance or sustainability would have been made possible by the climate stability that followed. So we can now look at major climatological and historical events over the 9,000 BC to 3,000 BC period, which was not the we stopped in the first table here. So we are looking at climate events, vegetation zones, again looking at warm periods as altithermal, so pre-boreal, boreal, mini ice age, so colder and drier by 6,000 BC, which had big impacts. Atlantic circulation changes, subboreal climate event and vegetation zones going from 9,000 BC to 3,000 BC. The human events associated with these: broad spectrum of hunter-gatherers in northern Europe, farming spreads rapidly in southwestern Asia that we mentioned before, linear Bandakarkaramic farmers, someplace in Scandinavia, move into Central Europe, first settlement of southern Mesopotamia, farmers in the Balkans, cattle herded in the Sahara, Etobol culture in Scandinavia, towns appear in Egypt, cities develop in Mesopotamia, and unification of Egypt as opposed to the fragmentation or regionalization of Mesopotamia during that period. And of course, again, climate triggers. Now Atlantic circulation resumes from the perturbation of the Lake Agassiz freshwater flux onto North Atlantic, and the collapse of the, or severe slowdown of the Atlantic meridional overturning circulation and the rapid cooling of the younger Dryas. Laurentide ice sheet collapses, Atlantic circulation slows with the 8250 event that we talked about. Euxine Lake, which was the present-day Black Sea, which was freshwater, got flooded by this, and sea levels rose, and the Black Sea got connected through the Strait of Bosphorus and became an inland sea. Warm moist conditions in Europe and drought in American West during this time of altithermal. The drought in American West is kind of a normal condition as long as the tropical East Pacific is cold. It tends to remain dry. It's west of North and South Americas and Mesoamerica. Major acidifications in Sahara, Egypt and Mesopotamia happened during 4000 to 3000 BC, which also overlaps with the Harappan period. So here is the Euxine Lake, current-day Black Sea, which connects through these straits here after the flooding, the Noah's flood that we talked about, and its drainages. So 12,500 BC, Eurasian ice sheet was still there, and you had all these drainages, Danube, Dniester, Dnieper, Don, and so on happening. Caspian Lake had glacial lakes that were draining into it as well, Ural Mountains, Lake Ural, and so on and so forth. Table 3 shows now major climatological and historical events from 3000 BC to AD 2003. So again, climate events and vegetation zones: subboreal, drought event in Eastern Mediterranean, drought event in Eastern Mediterranean again here. So this is 2000 BC to 1000 BC. Sub-Atlantic cooler weather in Europe. By AD 1, you are beginning to have the Roman period expanding and then shrinking. Medieval warm period, drought of 910 in Central America, event of 536 CE that we talked about. Little Ice Age, or AD in this language. Little Ice Age dominated this part, with climate triggers including El Nino event, the 300-year drought in Eastern Mediterranean after 2200 BC, major drought episodes and El Nino events. Not completely clear, but some evidences indicate that. Drought on eastern steppes, abrupt cooling around 850 AD, so bringing to the end the Viking expansion into Greenland. Major volcanic event causing cooling around here. Major droughts in western North America and central South America. Cooler, more volatile climate, many cold periods coming into the last millennium, and warming after AD 1860 associated with human activities. So here we had Old Kingdom Egypt, Sumerian civilization, Egypt reunified 2046 BC, Old Kingdom of Egypt ends in crisis, Akkadian Empire, collapse of the Hittite, Mycenaean civilization, Uluburun shipwreck, Shaw Moor, England in use, so the Moor expansions into Spain and so on. Caesar conquers Gaul, Celtic migrations, Biskupin. Avar Empire in Eastern Europe, decline of Rome here. Ancestral Pueblo dispersal, collapse of Tiwanaku, which we will look at, collapse of Maya civilization in the southern lowlands and Yucatan, and then of course Industrial Revolution. Those are the monsoon regions we have talked about. These were the changes in ecological zones over Europe during these periods, more recent periods than the ones we were looking at. 1200 to 300, 500 to 900, 300 BC to 300 AD, and late Holocene range of temperature over Mediterranean ecotones with seasonal migrations of these rain bands and so on and so forth. Okay, this is our empire and other polities in the first millennium AD. So you can see the various empires of the time over the Levant, Mediterranean Sea regions. So Roman Byzantine Empire occupied much of this region, and the borders of these various empires there shown as well. On the other side, over North America, you have these kind of climatic distributions. I won't go into details, but there is a major distinction between the regions with summer rainfall, and then on the western side of Colorado into western US, you have winter and summer rainfall, basically related to topography and winter precipitation, snow, and so on. This is the Tiwanaku as opposed to the Mayas we were looking at. So lake levels from Lake Titicaca correlated with the Andean ice cores and radiocarbon dates. So you can see the snow accumulation changes going from 480 to 2000, and you can see lake levels here, 20th century lake levels, AD here. So that's the baseline with which we are comparing the dry period and the wet period. So you can see the approximate time of the Tiwanaku collapse corresponding to below normal lake levels compared to modern lake levels. Okay, so you can see the snow accumulation changes happening here. So decreased quite a bit over this period, and then increased and decreased again over the Little Ice Age. The book concludes by a couple of paragraphs which are worth reading. There is no reason to assume that we have somehow escaped this shaping process in terms of climate impact on human civilization and vice versa. Agriculture is less visible to us now. The number of people growing food has shrunk from 90% of the labor force in Europe 500 years ago to less than 3% in the United States today. But we still need to eat. And now our vulnerability extends far beyond just growing food. Our crowded coastlines with densely packed high-rise and apartment buildings, our communication and transport systems, our abstract worlds of finance and scholarship and entertainment are beholden to the world's climate in ways both obvious and hidden. Like many civilizations before us, we have simply traded up in scale, accepting vulnerability to the big, rare disaster in exchange for a better ability to handle smaller, more common stresses such as short-term droughts and exceptionally rainy years. So all our inventions, agricultural, farm equipment, irrigation methods, groundwater mining methods, rainwater harvesting methods, drip irrigation, etc., are all considered good for shorter periods, but not necessarily for bigger, long timescale disasters. In the end, but if we have become a super tanker among human societies, it's an oddly inattentive one. Only a tiny fraction of the people on board are engaged with tending the engines. The rest are buying and selling goods among themselves, entertaining each other, or studying the sky or the hydrodynamics of the hull. Those on the bridge have no charts or weather forecasts and cannot even agree that they are needed. Indeed, the most powerful among them subscribe to a theory that says storms don't exist, or if they do, their effects are entirely benign, and the steepening swells and fleeing albatrosses can only be taken as a sign of divine favor. So this question of whether we are stewards of the environment or it's our job, God has given us the environment to be exploited, is always a kind of a discussion, at least in the biblical literature. Few of those in command believe the gathering clouds have any relation to their fate, or are concerned that there are lifeboats for only 1 in 10 passengers, and no one dares to whisper in the helmsman's ear that he might consider turning the wheel. So this is giving a narrative on how climate change is evoking or not evoking a response, or showing skepticism or denialism, and so on and so forth. So slightly longish podcast, but it doesn't matter. I wanted to cover the entire book in just one podcast, and it doesn't have the full context of the rich text that is in the book, but you should definitely read it if you want to follow up on any of this what we heard here. Okay.